Hi everybody. So I'm going to do a series of example problems from section 2.2. So we're going to start off with number 15. And the first problem reads, the quantity x plus 2 divided by 4 minus the quantity x minus 1 divided by 4 equals 2. The first thing that I'm going to do is I'm going to deal with the fact that we have a subtraction. And it's always a little bit difficult to remember this from my experience. So make sure that you catch that subtraction. You make that an addition and you pass the negative through, distributing it across the numerator. You can do either the numerator or the denominator, but do not do both. The reason I didn't do the denominator was because I already have a common denominator. I can combine like terms if I need to. And so if I'm going to solve this, if I'm going to work this through, I've already got a 4, and I can write the x plus the 2 plus a negative x plus the 1 is equal to 2. Well, so I end up with x and a negative x. They eliminate each other. So I have 3 over 4 is equal to 2. Well, that doesn't make any sense. So there's no solution to this one. There is another way to approach this problem. I could put x plus 2 over 4 minus x minus 1 over 4 is equal to 2. And again, I would begin by distributing that negative through. So addition, negative, positive. Now, I can multiply through each term, and I said term there, so terms are separated by addition, and they're bound by multiplication and division. So this is all one term, and this is all one term. So I'm going to distribute a 4 through. I'm going to multiply both sides of the equal sign by 4. So I put a 4 here, I put a 4 here, I put a 4 here, and those are getting multiplied by. And I think about it as 4 over 1. So that 4 and that 4 cancel. And that 4 and that 4 cancel. So 2 times 4 is 8. I have x plus 2 plus a negative x plus 1. And I end up getting 3 equals 8. Well, 3 doesn't equal 8. No solution. Okay? Typically, you'll end up getting some sort of x value, but I'm just trying to give you some examples of some goofy stuff that can occur. Okay? So we're going to deal with number 20 now, which reads 5 over x plus 1 plus 1 over x minus 3 is equal to negative 6 over x squared minus 2x minus 3. All right. Well, I'm going to go off and factor this one. Okay? And in the trying to save time, I'm going to recognize that I get it as x plus 1, x minus 3, and I have 5 over x plus 1 plus 1 over x minus 3. And again, you'll notice I have an equal sign. So if I have an equal sign, what I can do is I can multiply through by the least common denominator. I could get a common denominator throughout all three. It depends on how you like to approach it. A lot of people have seen this technique in the past. So you're going to multiply by x plus 1 and x minus 3, and you're going to put that for each term, and you'll have things cancel out. Now, if we had gone the denominator route, we'd still end up having to do the same thing, but you basically ask this. What does this denominator need that these have? Well, they've got an x minus 3. And so you'd multiply top and bottom by x minus 3. That's supposed to be an x minus 3. What does this denominator need that this one has and this one has? Well, it's the x plus 1. So x plus 1, x plus 1. This denominator has both these. It doesn't need anything. So effectively what I've done is I've recognized that my denominators all match. So I have 5 times x minus 3 plus 1 times x plus 1, or just writing x plus 1. And then I have x plus 1, x minus 3 is equal to negative 6, x plus 1, x minus 3. Well, I can multiply both sides of the equation by this. So x plus 1, x minus 3, x plus 1, x minus 3, and they cancel. So effectively, I could have done that at the beginning. I could have multiplied this term by x plus 1, x minus 3, and this term by x plus 1, x minus 3, and this term by x plus 1, x minus 3. And I would have had the same cancellations, and I would have, or similar cancellations, and I would have ended up with the same 5 times the quantity x minus 3 plus x plus 1 is equal to negative 6. Well, I'm going to distribute my x, and there's a 1 coefficient, so I'm just going to distribute that. So I have 5x minus 15 plus x plus 1 is equal to a negative 6. So I end up with a 6x minus 14 is equal to a negative 6. All right, so I'm going to add 14, I'm going to add 14, and I have 6x is equal to an 8. I will divide by 6, and I get x is equal to, after I reduce, 4/3. Now you should always check to see if that number violates the domain of these, but 4/3 added to 1 isn't an issue, and 4/3 minus 3 isn't an issue. And since these are the factors of that, you can plug the 4/3 in and you won't get a 0, and you can plug the 4/3 in as well into here and you won't get a 0. So you're okay, 4/3 works. Okay. All right, I will have to break this up into a couple videos. So I'm going to stop this here, and then I'll do some explanation in another video.